Hello, welcome back to Scholar Chef doing some Algebra 2. There we go. Today we're looking at inverse and joint variation and direct variation. In chapter 2, we looked at direct variation a little bit, and we have this equation y equals ax. Pretty basic equation. The non-zero constant a is called the constant of variation. Y-intercept of these is always 0, 0. Pretty basic equations. If we wanted to graph one, here's an example. Y equals negative 1/2 x. That means a is negative 1/2. And then we start at 0, 0 and just follow our slope. Rise over run, or fall over run in this case, down 1 over 2, down 1 over 2, down 1 over 2, up 1 over left 2, up 1 left 2, and so on and so forth. Oops, that's a terrible line, but you get the idea. And then also, this one we just quickly fix by multiplying x to both sides to getting y equals 5x, so a is 5. So up 5 over 1, up 5 over 1, down 5, left 1, down 5, left 1. Okay. As you should know, there's a lot of real-world applications. Some things directly vary with one another. You see with science, growth rate, height, stuff like that. One example is that if the more that you study, the better grades you get. Ha ha ha. I mean, it's true. So now in chapter 8, we're looking at inverse variation. So we say two variables, x and y, show inverse variation if they can be modeled by the equation y equals a over x, and when a is not equal to 0. The non-zero constant a is still called the constant of variation. Just go by my words, constant of variation. Just cross that out there. We say that y varies inversely with x because as one variable increases, the other decreases. So the equation y equals a of x can be solved for a for an equivalent statement. Solve for a now. So if I solve for a, I'll multiply both sides by x, so I'll get xy equals a. So if you see either this equation or this top equation that deals with inverse variation, saying y varies inversely with x. Okay. So the graph of an inverse variation is the shape of a rational equation, where the variable is in the denominator. So that's the general shape of the graph on the left here. We can't use 0. So let's make a table for this one. X, Y. Use some easy numbers, but not 0. If I plug negative 1 in there, I get negative 2. If I plug negative 2 in there, I'll get negative 1. If I plug 1 in there, I get 2, 2, 1. So 1, 2, 2, 1, negative 2, -1, -1, -2. So basically that's what's going on here. Boom. 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 So now we're touching 0. So an example of an inverse variation is that the length L of a rectangle varies inversely with its width, given a constant area. So if you increase the length of a rectangle, keeping the area constant, the width will get shorter. If you increase the width, the length will get shorter. Okay. So now we're going to look at joint variation. What extends direct variation to get the following. Z varies jointly with x and y, given that z equals axy. And you can even do it with more, saying this p varies jointly with q, r, and s. So let's go to the next page. Hopefully we can do some example problems here. Here we go. Lots of wording. Classify each as direct variation, inverse variation, joint variation, or none. So direct variation is y equals ax. Inverse variation is y equals a over x. Joint variation is like y equals a r s. I bet multiple variables basically, and then none of the above here. So xy equals 7. So if we remembered from the notes from the top, this is actually also another version of inverse variation. Because if we multiply both sides by x, we'll get xy equals a. So inverse variation, y equals x plus 3. That's our typical standard y equals mx plus b, so none of the above. If I multiply 4 to both sides, I'll get y equals 4x, so this is direct. And then lastly, y varies jointly with w and x, so this is a joint. So see how there's two different variables here. So that matches the joint variation. Okay, part B. Write an inverse equation or joint variation equation. So x and y vary inversely, and y equals 7 and x equals 4. Write an equation that relates x and y. So x and y vary inversely. So I can say y equals a over x. And they give us that y is 7 and x equals 4. So I'm going to multiply both sides. So 7 equals a over 4. Multiply both sides by 4. So a, our constant of variation that never changes, is 28. Well, for this particular equation. So my true equation is y equals 28 over x. Now we can find y when x is -2. When x is -2, y is -14, because 28 divided by 2 is 14. Number 2, variables x and y vary inversely. The point 112 lies on the curve. So this is our x, this is our y. Find the given values, write an equation. Okay. So once again, y equals a over x. 12 is y equals a over 1/2. Okay. So a equals 6. So our formula is y equals 6 over x. Now I can plug in 2. So when x equals 2, y equals 3. So those are my two answers. Lastly, the variable z varies jointly with x and y. So z equals AXY. And then they tell us that z is negative 75 when x is 3 and y is negative 5. So, simplify this a little bit. Negative 75 equals a times 15, negative 15. So divide both sides by negative 15. And you get 15, 30, 45, 60, 75. A is positive 5. So my equation, y equals 5x, or, no, z, sorry. Z equals 5xy. That's our equation. And then we need to find z when x is 2 and y is 6. 2 times 6 is 12. So z equals 5 times 12. That's 2 times 6. And so z is 60. Alright. Example 3 in book. Write an inverse variation model. We use models to write equations for. Read the information on page 520 to 552 for MP3 songs. Show the work to answer the following questions. So page 552, I do not have that. So this doesn't really work that well. But we're assuming that the number of songs varies inversely. Varies inversely with the average song size. So if the songs were long, like really long, then you would have less of them. If they're really short, you'd have a lot of them. And we probably looked at a table, and then we pulled if there was 4 songs, I guess. Sorry. If there was 2,500 songs, they would be 4 megabytes, I guess. This was probably on a chart of some sort. And then you have A equals 10,000. Not log. Go away, log. We're done with logs. 10,000. And then, so our formula would be N equals 10,000 over S. So make a table showing the number of songs that will fit on the MP3 layer if the average size is 2, 2.5, 3, and 5. So we just use our formula here. So if S is 2, 2.5, 3, and 5, plug it into our equation that we just made, and we'll get 5,000, 4,000, 3,333, and 2,000. So as the average size, well, I already said this, but as the average size of the song increases, the number of songs, number of songs decreases. Okay. Table below compares the current I in milliamps with the resistance R, so this is physics. Electrical circuits Determine if the table shows inverse variation. If so, write a model that gives r as a function of f. So we're looking at the table here. We're trying to see if it shows inverse variation. So we need to look at the a values here. And if it does show inverse variation, I just need to multiply x and y together. So 7.4 times 1200, that equals 8880. 8.9 times 1000 is 8900. So I'm just taking x times y. 12.1 times 750, 9075. And 17.9 times 500 equals 8950. So I'm going to go take out a calculator. Because in real life, when we're trying to make an equation, sometimes it doesn't, life doesn't exactly follow an equation. None of these numbers match. Well, duh, it doesn't, you can't, it doesn't strictly follow a direct variation. But it's pretty close. They're all around the same number, so we can make a guess for our constant variation. And what I'm going to do is put in all my numbers here. 8,880 plus 8,900 plus 9,075 plus 8,950, and then divide that by 4 because there's only 4 of them. So we could say IR is approximately 8,900. So I got 8,951.25. Use an easier number on yourself, 8,950. You can use 8,900. They're all about around that function. So note that I use approximately because not all these numbers match. So what I did is I added them all up and divided by how many there are, taking the average. So hopefully this one's not too confusing. The only reason why it does show inverse variation is because these numbers are quite close. They're not a huge difference from each other. If there were a huge difference, then there would be no evidence of inverse variation. So we're saying that our A value here is about 8,950. Okay. Lastly, word problems. Well, more word problems. So y varies inversely with the square of x. So y equals a over x squared. So number 2. X varies jointly. So jointly means, so x equals, so x varies jointly with t and r. So we have a here, t, and r. And inversely with s. So if it's inversely, they go in the denominator. If they're jointly, they go up top. Okay. So P varies. So P equals jointly with Q, R, and S. Don't forget to put A, Q, R, and S. And inversely with the cube of T. And then lastly, X varies directly. So X varies directly That means AY. So if it's directly or jointly, they go on top. And inversely on the bottom. Okay, hopefully this helps you out. That is direct variation, joint variation, and inverse variation. Have a good day.